All right, class. So today we're going to go over the solutions to the practice questions that I had given you last week. So please ensure that you take out the questions as well as your solutions so you can follow along to make sure that you haven't made any mistakes. So if you want to see the original documents or the actual answers to the question sheet, please see the attached PDF document that will be along with this video. So the first question was to calculate CPI, and so I'm showing you that the actual question here was the CPI information that you were given. And so here in this question, it gives you various pieces of data. So first it gives you the weight, how many of these things that are purchased. It gives you the prices in 2008, the prices in 2010, the prices in 2012. And so for this scenario, food is bought 15 times, clothing is bought 10 times, entertainment is bought 20 times, technology is bought 12 times. And so you can see in 2008, food was bought 15 times and it was costing 17 each. And so our spending on food is 15 times 17 in 2008. Our spending on food in 2010 is 15 times 18, and our spending on food in 2012 is 15 times 18.5. And so this is how you calculate each of the spendings. And so you need to do that for each of the different categories. So food, 15 times 17, clothing, 10 times 20 gives us this 200, 10 times 23 will give us this 230, etc., etc. And so if you do that for all four categories for all 3 years, you're going to get the values of 839, 920, and 991.5. And so this is what is being spent on in every year in 2008, 2010, and 2012. And so how do we get these CPI values from our spending values, our spending amounts? And so to get CPI, we need to use this equation here. It's CPI equals the current year spending divided by the base year spending times 100. And so we've chosen to create our base year in 2008 from the question. And so in 2008, our spending in the current year is 839. Our spending in the base year is also 839 because 2008 is going to be our base year. And therefore, 839 divided by 839 times 100 equals just 100. And so that is our CPI value in the base year of 2008. In 2010, our spending is now 920. Our base year spending is 839 still. And so 920 divided by 839 times 100 equals 109.7. And so our CPI for 2010 is 109.7. And if you look at 2012, 991.5 divided by our base year of 839 would give us 118.2. I just haven't given it to all of them. So this is how you calculate and create a CPI from baskets of spending and creating a base year as well. The next question asks us to calculate inflation. And so our inflation formula is to get the CPI now minus the CPI before divided by the CPI before times 100%. That could also be spending now minus spending before divided by spending before times 100%. But for our purposes, we'll use the CPI values. And so if you look at this chart here, you'll see our CPIs were 100, 109.7, and 118.2, which were calculated in the previous question. And so how do I get these values of 9.65%, 7.77%, and 18.18%? We use our inflation formula, CPI now, 2010, minus CPI before, 2008, divided by CPI before, times 100%, gives us 9.65%. Same token, if I want to look at 2012 to 2010, we look at our CPI now, 118.2, 2012, minus CPI before, 2010, 109.7, divided by CPI before, 109.7, times 100% gives us the 7.77%. And again, you can do the same procedure for 2008 to 2012, but it's just repetitive, so you can do that on your own to make sure you can get the right pieces of data. And so that's how you calculate inflation. The next question is asking us to calculate GDP growth, and specifically real GDP growth. And so if you look at the question, it gives us nominal GDP in 2008, 2010, and 2012. And so if we want to calculate real GDP growth, we need to find real GDP first and foremost. And how do we do that? We have to use nominal GDP and use that and take the deflator to get our real GDP. And so we go nominal GDP divided by GDP deflator times 100 will give us real GDP. So we have our nominal GDP is great. And so what is the GDP deflator? The GDP deflator actually is the CPI. And so the CPI values that you calculated in the previous question are below 100 for 2008, 109.7 for 2010, and 118.2 for 2012. And so using those values, we can calculate real GDP. And so real GDP for 2008 is just going to be 1.35 billion, just as nominal GDP is, because 2008 is our base year. So there's no backing out of prices because that's our original data. But if we look at 2010, our real GDP is 1.46 billion, which is the 1.6 billion nominal GDP divided by the GDP deflator, which is 109.7, which is CPI, which gives us 1.46 billion for real GDP. Again, you can do the same calculation with the 1.9 billion nominal GDP divided by the 118.2 GDP deflator to give you 1.61 billion for real GDP in 2012. And so we have real GDP now. But the question is still asking us, what is real GDP growth? And so how do we calculate that? We need to find a real GDP growth formula, which is just GDP now minus GDP before divided by GDP before times 100%. And so if we look at 2008 to 2010, we have 1.46 billion GDP now minus 1.35 billion GDP before divided by 1.35 billion again GDP before times 100%, and that gives us an 8.08% real GDP growth rate for those years. Again, you can use those same calculations using 1.61 to 1.46 here, or the 1.61 billion to the 1.35 billion for 2008 to 2012. And so, again, the formula is the same. It's just plugging in the numbers to get the correct calculation. And the next question is asking about fiscal policy. And so it says, show me on a graph aggregate demand for 2008, aggregate demand for 2012, relative to the full employment level of aggregate demand. Please label the graph fully for complete parts, etc., etc. So I'll talk through the explaining the reasoning. And so the data that's given in the question talks about our aggregate demand in these years, but it also gives us an unemployment rate that's hopefully going to give us a little bit of baseline to figure out what this should look like. And if I'm going to assume, and I didn't write this down, but if you assume that the natural rate of unemployment here in Canada is 6 to 7%, that's going to give us a little bit of context to use these unemployment rates. And so first thing is you're going to get your baseline graph. You have aggregate supply and aggregate demand at full employment, so that's where we want to be. And so if on a graph, aggregate demand in 2008, where unemployment is 7%, and so that's going to be pretty close to aggregate demand at full employment because we are in our range of full employment level of unemployment. We look at this rate, okay? So we look at aggregate demand very close up to getting towards full employment. And so if you see my graph here, and I have aggregate demand in 2008, and I show price level of 100. And why did I say 100? Because 100 is the CPI level for 2008. And so I've added in the actual CPI in terms of this graph on the axes. And so on the y-axis, or the x-axis for output, I've also added the 1.35 billion for real GDP. And so that's just a little bit higher level labeling and graphing so you can have a more accurate and more informative piece of data. If you want to graph the aggregate demand in 2012, you need to think about unemployment at 6%. And so if the natural rate is somewhere between 6 and 7%, an unemployment rate of 6% is actually much better. And so that should be above aggregate demand at full employment. How much above you want to put it is going to depend on how you interpret things. Again, it should be relatively close to the full employment level of aggregate demand. But why did I push it up quite a bit there? I pushed it up quite a bit there because in our data, our CPI is 118.2. And that's a huge departure from the 100 CPI level for aggregate demand 2008. So you could potentially have moved this up even higher based on that inflationary level. So it's up to you. It's interpretive, but it has to be higher than aggregate demand at full employment. Probably not super close because there has been inflation. And again, I put down 1.61 billion for real GDP here. So that should be what roughly your aggregate demand and aggregate supply graph looks like. And so that's why I've added the CPI levels, and I've also added the real GDP output levels. So the next question is asking us about shifts in aggregate supply. So depending on how you interpret this question, I've given you a little bit of data, and so I've added a piece of information that says that the population has increased from 2010 to 2012. And so you could take more information from the rest of the questions if you want, but this is meant to be relatively simple. And so if your population has increased from 2010 to 2012, we're looking at a scenario of aggregate supply shifting. And so if population increases, that means that our capacity to produce will also increase because we have more people. So our our production possibilities frontier has gone out. Also, prices should shift lower because there's going to be more competition for jobs, and prices can drop. And again, this is all theoretical. And so aggregate supply should decrease in price and increase in capacity. And so this is an outward shift in aggregate supply because of a population increase. And so that's the entirety of the problem set review and solution. So please, again, if you have any questions about any of these solutions or any of the questions on any of the homework other than this, please send me an Edsby message and I'll get back to you as soon as possible. And please prepare for your upcoming test. Thank you very much.